Hi everyone, I'm Christina and welcome to the 8th video in our A-level trigonometry series. In this video, we're going to focus on how to sketch the graphs of the trigonometric functions. And our objectives are to sketch the graphs of sin x, cos x, and tan x, and to identify and use key features such as the x-intercepts, where the maximum and minimum values occur, and where the vertical asymptotes are. This is specifically for tan x, because tan x is our function that has vertical asymptotes, okay? So for all of my graphs, I'm going to sketch them over the domain from -2 pi to 2 pi. So we can see the full shape and how it repeats itself as all of our functions are periodic. So we're going to start with y equals sine of x. Now, the x-axis crossings for sine of x are at -2 pi, -pi, 0, pi, and 2 pi. The maximum points of 1 occur at -3 pi over 2 and at pi over 2. And the minimum points of -1, so scroll down so you can see that, the minimum point of -1 occurs at -pi over 2 and at +3 pi over 2. So we're going to try and join all of this together with one smooth continuous curve. So I'm going to show you how I sketch it first on the right side of our graph, and then I'm going to show it to you on the left. So we're going to start at 0 because that's where it crosses, but remember there is a maximum point here, and then the sine graph, the sine graph travels through here. Let me try that again. Maximum point at 1, goes through pi, comes down to -1 at 3 pi over 2, and then again it intercepts at 2 pi. And if we try the other side, so it's coming down to -1 at -pi over 2, crosses the x-axis at -pi, maximum value at -3 pi over 2, and then back at -2 pi. So something like this should be fine, okay? But it should be as close as you can get it to a smooth continuous curve for our sine graph. So we can generalize these features using the fact that the sine function is periodic with period 2 pi. We can say that all of these x-intercepts occur at x equals n pi. We can say that the maximum points occur at x is pi over 2 plus 2n pi, and that the minimum points occur at x equals 3 pi over 2 plus 2n pi, where n is an integer value. Okay, so we're going to do the exact same thing for our cosine function. So for y equals cos x, again, we're completing 2 full cycles because our domain is from -2 pi to 2 pi. So the graph starts at a maximum of 1 at x equals 0, and then it's going to cross the x-axis at -3 pi over 2, minus pi over 2, pi over 2, and 3 pi over 2. So the maximum points will be occurring at -2 pi, 0, and 2 pi. And the minimum points will occur at -pi and pi. And remember that the cosine function is symmetrical. So let's try connecting these points. So I'm going to start here. So it's going to intercept at pi over 2. It's going to come down to a minimum value at pi, again crossing the x-axis at 3 pi over 2, and coming back up to 2 pi for its maximum value of 1. And we're just going to draw this now on the left-hand side, and it should be fairly easy because it's symmetrical. So coming down there, minimum value there, intercept there, and oh, not the best line there. Let me redraw that slightly there. And then, yeah. Okay, so that's our cosine sketch. So again, just trying to get it as smooth as possible. And then again, we can generalize here because our cosine has a period of 2 pi, so it repeats itself every 2 pi units. We can say that it will always, the x-intercepts for cosine will occur at x equals pi over 2 plus n pi. The maximum points occur at 2n pi, and the minimum points occur at x equals pi plus 2n pi, where n is an integer value. So finally, for tan x, again, sketching over the domain from minus 2 pi to 2 pi, the tangent graph completes 4 full cycles. So the x-axis crossings will be at minus 2 pi, minus pi, 0, pi, and 2 pi. And I've actually already sketched the vertical asymptotes. So let me put in where these vertical asymptotes actually occur. So they're going to occur at pi over 2, 3 pi over 2, minus pi over 2, and minus 3 pi over 2. So between each pair of asymptotes, the curve increases without limit. So we're going to sketch it smoothly, approaching the asymptotes, but make sure it never touches the asymptotes. So I'll show you that here. I might extend these a little bit. And now I can give a sketch here. So the tan graph is approaching, but it never touches those asymptotes. And the same thing is happening on the right here. So it's approaching. And again, you repeat that tan graph here, making it a smooth, continuous curve, approaching the asymptote. Doing the same thing for minus pi there. Ooh, just being very careful not to actually touch it. And then ending it at 2 pi. And then here as well. Like that. So that's a sketch of our tan graph from minus 2 pi to 2 pi with all of the asymptotes and x-intercepts labeled. So we can generalize again because the tan function is also periodic, but it has a period of pi instead of 2 pi. The x-intercepts occur at x equals n pi, and the asymptotes occur at x equals pi over 2 plus n pi, where again, n is an integer value. So to summarize, when sketching the trig graphs, we choose a suitable domain, we can plot the key points and draw a smooth, continuous curve.